Cold fusion, the process of nuclear fusion at room temperature, although hypothetically sound, is an expensive and inefficient means of energy and is outclassed by methods such as solar and wind farming. In 1989, two scientists, Martin Fleischmann and Stanley Pons, shook the world when they announced they had achieved cold fusion in a laboratory at the University of Utah. They announced that they had achieved a nuclear reaction at room temperature in a container as small as a test tube. Since then, many scientists have attempted to replicate this experiment, but most have failed. Many claim cold fusion to be a ridiculous fantasy due to it being unreproducible and have abandoned the idea of researching it anymore. But to further delve into the real-world implications of cold fusion, we must first discuss the chemistry taking place. Essentially, cold fusion is the process of a nuclear reaction at temperatures far lower than a nuclear reactor. It is a reaction that generates heat without burning chemical fuel. A cold fusion cathode operates at a temperature of around 100 degrees Celsius, while nuclear reactors operate at 300 degrees Celsius. While only operating at a third of the temperature, cold fusion has a greater power density by volume ratio, 300 watts per centimeters cubed, compared to a nuclear reactor's 180 watts per centimeters cubed. Pons and Fleischmann use deuterium as their fuel in cold fusion experiments. According to the University of California, deuterium, an isotope of hydrogen, contains one neutron, while hydrogen has none. They use deuterium instead of hydrogen because deuterium reactions create 30 times the amount of energy that hydrogen would. They also use palladium because it has the unique ability to take in many more hydrogen atoms than usual. In order to fuse the two atoms together, they needed to overcome the electrostatic force in between the two atoms, known as the Coulombic barrier. Both atoms have a positive charge, and the repulsion force between the two is very strong. The scientists used palladium and deuterium in hopes to overcome this setback and create fusion. However, the issue with cold fusion is that this is all hypothetical, with many scientists discrediting the practice. According to Sagheer, overcoming the Coulombic barrier is physically impossible at temperatures lower than a few million degrees. Stephen B. Crivet, a lead cold fusion researcher, states that fusion reactions create heavy elements out of lighter ones, and doing so requires so much energy that not even a collapsing star could do the trick. The only way on Earth to complete such a task would be in a nuclear reactor. He states that, quote, cold fusion has no merit, end quote. Although the idea of attaining cold fusion is very attractive, it is very impractical as the results from experiments are not reproducible and it will cost an enormous amount to research with no guarantee with the results. Wind or solar farming will prove to be a much better alternative. Both of these options are renewable, clean, and attainable. We can easily predict wind patterns and times when the sun will be out to maximize energy output. In fact, according to the Earth Policy Institute, the amount of energy from the sun touching Earth in just 1 hour is enough to power the entire world for a year. If we could harvest just a small percent of that energy, the energy crisis would be solved. Investing time and money into researching and developing ways to harness these types of energy will serve to have a much greater payoff in the future. In conclusion, although the fantasy of cold fusion may sound endearing, it remains to be just that, a fantasy.